I don't know if he's gonna come back and turn the mic on or if it's on right now, if the camera's on. Oh, everything is on. Okay. Oh, we're going. Okay. Okay. Hi. Welcome to the workshop. My name is Emily Herbert. I'm here with Fuel Labs. Actually, Ruben and Matt are also here with Fuel Labs today. So I'm really excited to do the workshop. You're here in person, and then there's also people on the live stream. Just so that I can kind of cater the workshop, I'm hoping to understand, are you planning to follow along on your laptop, or are you just hoping to follow along as I'm coding on the screen? Okay, then we'll do that. So today I'm going to give an overview of Sway, an overview of Fuel, and yeah, thanks Ruben, and kind of introduce you to what it's like to write your first smart contract in Sway. We'll do like a 5 to 10 minute primer about what Sway is, how you might think about Sway in the context of all of the things happening in Web3, and then we'll actually dive into the code. So if we were doing the workshop live, and for those of you following along on the live stream, you'll want to install Cargo first, and you can do so using RESTUp. And next you'll want to install Fork, and you can do that using FuelUp. I'm going to go ahead and proceed, but if you need to install FuelUp and you need to figure out how to do that, you can navigate to the materials that are at the bottom of this page, which are just on my personal GitHub at the ECC hack-workshop repo. And in fact, all the materials for the workshop are on there. What is Sway? Sway is a smart contract language built for the blockchain. It has components of both Solidity and Rust. So what does that mean? Sway, the purpose of Sway is to empower users in terms of its power and its expressivity. And it does that by allowing users to build smart contracts using an expressive language built for the blockchain. So much of the elements of Sway are blockchain specific, so you can perform contract storage, you can do cross-contract calls, and much more, much that you would in Solidity. But the design of Sway and the feel of Sway and the developer experience around Sway is very similar to Rust. So as we'll see today, the code around Sway and the way that we're interacting with Sway feels very similar to Rust. Sway currently is built for the FuelVM and the Fuel ecosystem. In the future, we'll be targeting an EVM backend. But right now, when you write Sway code, it's compiled and then deployed on a Fuel network where it's executed on a Fuel virtual machine. The Fuel VM comes with its own set of benefits, which I won't get into in this talk. But at a high level, you can think of it as a highly parallelizable UTXO-based transaction scheme that offers you a lot of benefits based on its inherent properties. If you want to know more about that, you can go to our website, fuel.network. Okay, so now for the quick 5-minute primer, which will give you enough understanding to where the code will actually make sense. So when we're writing Sway code, we need a way to compile it and deploy it. So we need a build system. And the build system that we use with Sway is something that we've also developed at Fuel, and it's called Fork. You can think of it like the Fuel orchestrator. So Fork is the project and dependency management system. It's used to compile, build, deploy, and test smart contracts. You can use it to start local Fuel networks and a lot more. It's the equivalent of like Rust Cargo. Have you used Rust? Okay, so a lot of this will feel very familiar to you. Yeah. To create a new project, you can use Fork new. Here we're just passing in a custom name, and we're telling Fork that we want to create a new smart contract. We can navigate into the project that Fork creates, and we see that Fork creates this skeleton project structure for us. At a high level, every Sway project has 4 components, and we can see here what they are. So it has like a cargo.toml, a fork.toml, a source directory, and a test directory. The fork.toml has the information in it that Fork needs to compile. So it has like the name, the version, all your dependencies, just anything fork would need. The source directory has your Sway code. The entry point is always going to be the main.sway file. And then the test directory has your test code. So you can see here that the test directory actually has Rust code in it. And that's because fork under the hood uses Rust. So when you're writing Sway code, you're able to write your tests in Rust, and you're able to use the Fuel Rust SDK to access your Sway contracts. So the Fuel Rust SDK allows you to do everything that fork would do. So you can compile, build, test your Sway contracts, run a local fuel network, all inside of Rust itself. And this, you can do more than this, more than just testing. Like you could build a whole Rust project that interacted with a whole Sway project, but the most common application that we're seeing right now is in testing. And that kind of loops into why we have the cargo.toml file, is that's allowing fork to do this compilation. To build a Sway project, you can use fork build. Here we can see it build our Sway project. And to run the tests, you can use fork test. There's more things that fork can do, but this is just a quick overview. Now to talk a little bit about what Sway offers. So you can declare variables much as you would in Rust. You can use the let keyword to declare a variable. You can use the mute keyword to declare a mutable variable. And you can use the type description syntax to add a type description. Functions look like this. We use the function keyword, pass in the name. Here we have two parameters, one of type U64, one of type Boolean, and it returns a string of length 4 called done. In Sway, you define a contract by doing two things. First, you define the contract ABI, and then you implement that contract ABI for a contract. So here we have our ABI called simple auction, and it has one function. And then we implement the ABI and implement that one function. The benefit of this is that these ABIs, the ABI definitions, are exportable and shareable. In this particular example, the ABI definition is co-located with the implementation, but you can have these in totally separate Sway projects if you wanted, or in separate files, and you can share them, and you can export them, and say you wanted to have...
And import them?
Yes. Okay. So say you wanted to have like 3 different kinds of simple auctions. You could define the one simple auction ABI, and then you could implement 3 different contracts that all use that same simple auction ABI. Yeah.
Is there a library that we can access for functions?
Well, I'm sorry, what do you mean?
Open source libraries that we can, because someone else has already written an auction.
Yeah, so us at Fuel, we have some applications that we've already written for developers to get them started. Yeah. If you go to our official like Fuel Labs GitHub, we have like a fundraiser example, an escrow example that have some pretty complicated ABI examples that might get you started. Yeah. To use contract storage, you use this storage keyword. So here we have storage with one variable called myData. Then to access storage, you can use this storage dot syntax. So to write, you can use storage.myData with an equal sign, and to read, you can just call storage.myData. In Sway, when you're accessing storage, you need to annotate the functions that are accessing storage with this storage annotation syntax. So this syntax and these annotations allow Sway to make certain guarantees and make certain optimizations based on the fact that you're letting it know that you definitely want to read and write from storage. So say that this said, I just want to like storage parentheses read. Sway would say, hey, are you sure that you want to write to storage here? You just told me that you want to read. Like it would make sure that you want to do that. Just talking about storage more, Sway offers some specialized data structures to allow you to store complex data in storage. So one of these is called storage map, which is just a mapping for storage. Here we have a mapping from U64 to Boolean. We have 2 functions, one that inserts a number into the storage map and one that gets the number from the map. We can see that the insert function just takes a U64 and a Boolean and calls .insert, and then the get from number function takes a U64 and gets the Boolean from the map by calling .get. If you want to know more, so you can also have structs in Sway. So a struct The syntax looks very similar to that of REST. So here we have a struct point that has a x and a y, both of U64, and you can define methods on structs using this impulse syntax. Sway has generic types. So here we have a struct data that has a generic type T. And again, you can define impls that take generic types. Sway has enums. So very similar to REST, Sway offers the option enum, which has the sum, there's some data, and the none, there's no data variant. And then it offers the result succeeded, and or the error, there's been an error variant. Okay, now we're actually gonna get into the workshop. So today we're gonna be building like a fundraiser smart contract. So the purpose of this smart contract will be, it's an application that is a platform for fundraising. You can think of it like a simple implementation of like Kickstarter or something like that. So we're gonna write functionality that accepts fundraising proposals, that cancels fundraising proposals, allows users to pledge campaigns, and allows campaigns to be complete and the assets to be sent. So essentially getting into the details, what it's gonna do is the proposal, or the smart contract that we're gonna write is gonna allow external users to call the smart contract and to define addresses for which they want as a beneficiary, and when there's been enough funds sent to a particular proposal, those funds will go to the beneficiary that they defined at the proposal creation. Okay, now we're gonna actually build it. So for anybody following along, the code is posted here, but we'll also be writing it up today. Okay, so this is very small. Okay, can you all read that?
Yeah.
Okay.
Maybe a ton of words.
Oh yeah, good point.
Yeah, better.
Okay. Okay, so just to go over like the setup, here's the editor. I'm just using VS Code personally, and then when I do this little scroll thing, I'm just going to the terminal to do the compilation. And I'll actually make this a little bit bigger. Okay, today we're gonna be using test-driven development. So what I've done for this example is I've pre-written, hi.
You Matt? Oh, Matt. Yeah. Hi, Derek Silva. Okay. From one of the organizers. Oh, hey. Nice to meet you. Not just a random Derek Silva. Okay, great. So you're here. I'm going to let everybody know that this is starting soon.
The workshop's going right now.
Stream.
Shoot. Okay. Sorry. That's going to be funny.
Yeah, so I've pre-written some tests for us, and I've pre-written the skeleton code for our contracts, and we're going to be filling it in and then watching the tests start to pass as we fill in the tests. At a high level, we're building this fundraiser smart contract, like I said, and in order to do that, we're actually technically going to build two different contracts. The first of which is an asset, and this is the type of this asset contract is going to be the asset that's accepted by our fundraiser. So you can think of this like, okay, we want our fundraiser to only accept like a certain type of coin. But we need to first define what that coin is. Like we need to define the contract for that coin. So that's what we're going to be doing. And that's this asset directory you see here. Once we do that, then we're going to be going into defining the fundraiser contract itself and completing those tests, like I said. So first thing we'll do is we'll check out this asset contract. And here inside of the asset directory, we can see that there's a little bit more stuff because I was working on this before, but there's this basic directory structure. There's the source file, the test file, the cargo.toml, and the fork.toml. if we look at the main sway file, here's the skeleton code. I'll walk us through what all of this is. At the top, there's this word contract. In Sway, there are 4 types of programs. In this example, we'll only be talking about contracts, and that's what this is. This line is telling Sway that we're looking at a smart contract. Next is a declaration for the dependencies. I won't get into Sway's module and dependency system, but you can basically think of it like Rust module and dependency system. Next is the ABI definition. This ABI definition is called asset. It has one function called mint and send to address, which will do exactly what it says. It'll mint our token, and it'll send it to the address that we provide. And then next, we're actually implementing the ABI for the contract. So what we want to do is we want to fill in this to-do and allow it to mint and send to address. Okay, so it says to do mint tokens and then send them to the address using the mint to address function. This mint to address function is provided by the Sway standard library. So us at Fuel have pre-written a really extensive Sway standard library that pre-packages like a bunch of data structures and functions that already do a bunch of the heavy lifting for you. So like we've already written this mint to address function for you that basically does all of this functionality. And we have a transfer function, we've already written revert. The standard library is quite extensive. So we'll just go ahead and implement this. So we'll say mint to address, and we'll pass in the amount, and we'll pass in the recipient. Okay, now that we've written that, we will navigate to our directory and go into the asset, and we'll build it with fork. And it builds, great. So the asset contract is done. That's all we have to do to write a contract that mints a token and sends it to an address. Now we can actually build our fundraiser contract. The fundraiser contract is a little bit more complicated, and we'll start out by looking at the ABI definition. The ABI definition has more than one function. It has an initialize function. We're going to use this to initialize the fundraiser contract, and is initialized checks to see if the contract has been initialized. A get campaign. So when we're making the campaigns and submitting the fundraising proposals, we'll call those campaigns. So this gets a campaign based on a campaign ID, a function to create a campaign that takes a beneficiary and a goal amount. So this is when a user says, oh, when I have a certain goal amount, I want to send it to this beneficiary, this address, or this identity, and that will return a campaign ID, a cancel campaign function, a pledge function, which will allow a user to pledge a certain amount of tokens, and a complete campaign, which will check to see if the goal has been met. Next, we have a struct, which will represent our campaign. This struct has a couple elements. So an author, the person that submitted the campaign proposal, a beneficiary, the person that will receive the funds, a goal amount, the current amount, tracking how much of it has been funded, and a Boolean to see if that proposal is active. Next, we have an enum to represent state. So this will just tell us if the contract is initialized or not initialized. We also have a file for representing our errors. So here we have like errors for if, like I've already pre-written all of these and we'll see them used in the example, but we can pull from these if we want to represent different errors. So like if we want to say, okay, if we've tried to complete the campaign but the target hasn't been reached yet, we would use this error. And we'll see that as we go through. Okay, now to get into writing the code. Again, we see this contract definition. Here we have the dependencies and the module system. I won't get into that too much because it's beyond the scope of this workshop. And then we have our storage declaration. The storage declaration is the contract storage, and we have 4 different elements. We have the state, which is telling us if the contract is initialized. We have an asset. This is the part of the contract storage that is keeping track of the type of asset that is accepted by the fundraising contract. So this is the type of like coin that the fundraising contract accepts in terms of the pledges. We have value keeping track of the next campaign ID so that we can insert more campaigns, and then a storage map keeping track of all of the campaigns that have been created so far. Okay, here is where we're actually implementing that fundraiser ABI for contracts. Before we implement anything, we're just going to build it and run the tests just to see what our starting point is. So we'll go into the fundraiser and we'll run fork build. Okay, everything builds. And now we'll run fork test. What? Okay, so apparently some people have updated their libraries overnight.
Can you show us maybe the next one line?
Yeah. So the tests that are running are inside of this test directory, and they're in Rust. So they'll look pretty familiar to somebody that's familiar with Rust testing. But what they're doing is, oh, they're in here. So what they're doing is they're testing the functions that we're going to be running. So this one is testing that mint and send to address function that we wrote earlier. So it's doing a setup test function that's basically grabbing like a handle on the asset and deploying it, and then it's checking the balance of the asset in the wallets for 3 different users, and it should be 0 to start out with. Then it's minting 1 million, 2 million, and 3 million asset coins, and then checking that the balance in each is like 1 million, 2 million, and 3 million. Okay, yeah, so this is exactly what we expect. We expect that all of the tests fail except for the deployer can mint function, because this function uses the asset and nothing in the fundraiser. Excuse me. So as we're filling out fundraiser, the stuff in the fundraiser application, we'll see that the tests start to pass. Okay, so we're going to fill out the initialize function first, and here we have our to-do, set storage state to the state.initialize. So we'll say storage.state equals state initialized storage dot, and then number 2 is set storage asset to the asset passed into the function. Set storage dot asset equals asset. So then we'll run fork test again. And fork test also runs fork build under the hood. So when I'm running fork test, it's also running fork build. Yeah, we can see here that an additional test passed and 1 less failed, which is what we expect. Because the new test passed is the one that says deployer can initialize the fundraiser contract. Okay, next we're going to look at the isInitialized function. This one is checking to see, okay, from our state, if it's initialized, we're returning true. If it's not initialized, we're returning false. This one's already implemented for us. Our next function is getCampaign. What we're checking here is, okay, we want to require that the storage.state is initialized. If it's not initialized, we want to revert. And then we're going to revert with the error that we saw earlier, which is the creation error, contract not initialized. Next, we want to require that the campaign ID is less than the storage dot next campaign ID. And if it's not, we want to revert with a user error, invalid ID. And then lastly, in order to get the campaign at the specific campaign ID, we just call storage.campaigns.get of campaign ID. Okay, now we're going to implement the create campaign function. The first to do is get the user that called the contract with the function message sender. So we'll say let user equal message sender. Then it says this function returns a result, so you'll need to use message sender dot unwrap. Okay, so this will get the user. Create the campaign using the struct syntax. Set the author to the user from step 1, the current amount to 0, and is active to true, and then the beneficiary and amount from the arguments. So we'll say let campaign equals campaign with the author as the user, then the beneficiary, the goal amount, the current amount to 0, and is active to true. Okay, step 3, get the campaign ID from storage.next campaign ID. Oops. So we'll say let campaign ID equals storage.next campaign ID. Step 4, insert the campaign into storage.campaigns using the ID from step 3 and the campaign from step 2. So we'll say storage.campaigns.insert with the campaign ID and the campaign that we created. And step 5, increment the storage.next campaign ID. So we'll say storage.next campaign ID plus equal 1. And step 6, return the campaign ID from step 3. So that is just campaign ID, and then we will remove this. Okay, so now we'll test this and see if we've implemented it correctly. I hope so, because live coding is hard. Okay, great. So we can see that another test passed, and we can see the test that passed is the user can create campaigns test. So we've done it correctly. Okay, the next one we'll write is the cancel campaign. Essentially, we want users to be able to cancel their campaigns if they so choose, if they decide that they don't want the person to get any more money anymore. Okay, step 1, get the campaign from storage.campaign. So we'll say let campaign equal storage.campaigns.get with the campaign ID. Get the user that called the contract with the function message.sender. This function returns a result, so we'll need to call unwrap. Set the campaign.isActive field to false. So we'll set campaign.isActive false. And because we're setting this, we need to make the campaign mutable. And then reinsert the campaign into storage.campaigns.
So by default, a variable is immutable, right?
Yes. Oh, I don't know why this, I don't even think this is necessary, getting the user. We'll run the test. Okay, so we can see that another one passes called users can cancel campaigns. Yeah, so by default, a variable is mutable and then, or immutable, and then to make it mutable, you add the mute keyword, similar to Rust. Okay, so now we want to write a function that allows users to pledge money. So first step is get the campaign from storage.campaigns. So we'll say the campaign is storage.campaigns.get with the campaign ID. Get the pledge amount with the function message.amount from the standard library. So we'll say let pledge amount equals message amount. This returns a result, so we'll need to unwrap it. Increase the current amount on the campaign by the pledge amount from step 2. So we'll say campaign dot current amount plus equal or equals plus equal equals campaign dot current amount plus the pledge amount. And then we'll reinsert the campaign into storage.campaigns. So we'll say, oh, and because we're updating the current amount, we need to make the campaign mutable.
Okay.
Yeah. So then we'll reinsert the campaign into the storage.campaigns. So we'll say storage.campaigns.insert with the campaign ID and the campaign. And we'll test this. Oh, this is message amount. Oh, okay. Sorry, I spoke too fast. So the message amount doesn't return a result. It just returns a U64. And this is actually a really good time to demonstrate the... So one of the focuses of Sway is on the Sway compiler messages. We, at Fuel, really hope to deliver compiler messages that are useful to the users. And we spend a lot of time thinking about what the compiler messages will say. In this particular instance, this compiler message is saying, okay, there's no method named unwrap, which is the method that we called here, on the type U64, which is the type returned by message underscore amount. So basically what this is telling us is that we're not able to call .unwrap on U64 and that we should remove it. So we'll do exactly that. Awesome. And we see that, again, another test passed. We can see that users can pledge now passes because we successfully wrote the pledge function. And lastly, we're going to write the complete campaign function, which is going to allow us to transfer the assets to the user, to the beneficiary, if the campaign goal has been met. Okay, so step one, we're going to get the campaign from storage.campaigns. So we'll say campaign equals storage.campaigns.get campaign ID. Set the campaign active field to false. So we'll say campaign is active equals false. Again, because we're updating this field, we need to make this value mutable. Going to reinsert the campaign into storage.campaigns. So we'll say storage.campaigns.insert with the campaign ID and the campaign. And then we're going to transfer the total pledged to this campaign to the beneficiary using the transfer function. Again, this transfer function is a function supplied by the Sway standard library, and it looks like this. So the transfer function takes an amount, an asset ID, and a to, an identity, which in our case is the beneficiary ascribed to the campaign. So we will say transfer the amount, which is the campaign.current amount, the total amount pledged to that campaign. The asset ID is the type of asset that the fundraiser contract has decided to accept. So that's the storage.asset. And then the to is the beneficiary, so that's the campaign.beneficiary. And what this will do is it will transfer those assets to the account that's at the campaign.beneficiary. I believe if we ran this, it would work, but there's one issue is I don't think that we want to send the funds if the funding goal has not yet been met. So we're going to insert one additional thing, which is we're going to add a require statement to check to make sure that the funding goal has been met. So we're going to say we want to require that the campaign.current amount is greater than or equal to the campaign.goal amount. And if it's not, we're going to look at our errors library and return the error target not reached. So we'll say, oh, I already forgot what it was. Campaign error. Okay, so this require statement is saying, I want to require that this conditional is true. And if this conditional is false, I'm going to revert the contract call and revert it with the value of this argument, which in our case is the enum variant campaign error target not reached. So we'll run the test.
I have a question.
Yeah.
So, does it matter that the require happens after campaign is active is set to false? Does it just not update the state if it reverts?
Oh, that's actually a really good point. We should be putting this before the is false. So here we'll put it here. Thank you for pointing that out. Okay, yeah, so we'll just run it again for posterity. Yeah, and we can see that all the tests passed because we've successfully written our fundraiser contract. So now we can go and raise money for our beneficiaries. Yeah. Great. So now that we're complete with that, I'll just go back to the slides. So today we covered obviously the contents of the workshop, the contents of the example. We also talked about what Sway is in general. We talked about how to get started with Sway and Fork and how to write our first smart contract in Sway. Fuel has just started our first Fuel grant program. So if this kind of thing was exciting to you and you're interested in building more smart contracts with Sway, you're welcome to apply to our grant program. So we have applications open now and programs available between 10 to 150K USD available. So thanks. So on the left is the QR code for the grant form, and then on the right is the Twitter, both of which are accessible on our website, fuel.network. And then there's also my Twitter on the right, and the Sway Twitter, and the Fuel Twitter as well. So thanks.
Nice.
Yeah. Thank you. I think so. Yeah.
I was like, are we being recorded right now?
my train ticket. The attendant at the train.
It's demagnetized again.
No, it's not. Because he gave me a new one, and he also got a little mad at me because apparently you're supposed to write your name down and circle the day that you bought it. Because I bought one of these 5-day ones. And he was like, you could get fined 35 euros. And I was like, please don't fine me. And he didn't. He just gave me a new one. And he made me write my name down. Yeah. But then I missed my train.
This was recorded.
Oh. Oh, no.
The government comes after you.
No. I'll pay. I'm sorry. I paid. Okay.